Hello everyone. In this video, we are going to learn how encryption or decryption works in cryptography. We will understand through a very basic example. We will not jump directly into understanding the jargons in this field like public key, private key, how it works, how it is used, and all. So we will start with a very basic example. The example is, let's say, I have a user called A, and this user wants to send a message hello to user B. So I have a person A who wants to send a message to person B. Okay, and the message is hello. So what are the ways and what are the challenges are we going to get? We are going to navigate our whole scenario understanding through this story. Um so way one is going to be way one one way one is going to be, let me use this, yeah, instead of this. Way one, way one is going to be a user, this person A can simply go and meet in a park. They can decide, they can communicate with each other, hey, let's go and meet in this park, and select a time where no one else is visiting that park, so that I can share this message with you, and also maintain that this message is not being shared with anyone else. So the secrecy is there. So they will decide a park, go and meet there. A will share this message hello with the other user B, and the B has received this message and also made sure that this is not being received by any heard by anyone else. uh, Task is completed. But what are the problems that we have faced here? Problems are that both A and B have to move out of their houses, and then they have to select a place in such a way that this place is not, that time is not being crowded with anyone else. So this is one way. I'm saying there could be a better way. What is that better way here? Let's just discuss about that. Let's shorten it. And yeah, uh, now this is one way. Now I'll say way two. Way two is, I will say way two. Way two is, let's say, um, we are using some sort of a way or a method. Solution is use a way to uh, encode this message so that no one else is able to understand or decode it. What do I mean here is, let's say I write this message in such a way, hello is written in a form like x this way, and the whole meaning has changed, and anyone who's reading this fsdafas will not be able to understand what does it mean. So if we find that way, anyone reading that message or hearing that message will not be able to take out the meaning of that message. Okay, so what I'm going to do here is, I will use a way here only to better help you understand this is, let's say, yeah, this way. So what I'm going to do here is, let's say I'm using a mechanism. This method is, let's say A, B, C, D, E, F, G. I have written the whole A, B, C, D to Z here, and I'm writing everything from in a reverse way. Where A, if I'm writing A, I will write Z instead. If I'm writing B, I will write Y instead. C, X instead. And now, and I think you'll understand the gist. So in this way, I am going to encode my message. So my message, hello, this was the original message. Hello will be uh, encoded to, hello will be encoded to hello will be encoded to, if we see, H represents S, E represents V, uh, H E L represents O, again O, and O represents is L. So if you see, the whole message is now encoded to SVOOL, swool. Now we will encode this message using this thing, and we will call it a key to encode it or decode it, to encrypt it or decrypt it. So this changing the whole meaning to something which is not understandable by the other person who has no idea how to decode it is called it, this process is called as encryption. So we will start to call it encryption. So this hello has been encrypted to swool using this thing called key. Now this thing called key, okay. So now the B is aware of this, that key. B knows about this thing. B knows about the decryption way. The same method can be used to convert swool back to hello, right? So we are going to use a mechanism where A is going to encrypt using the key, and the meaning has been changed to swool. Now it has been changed to swool. Since B also knows this, is going to use the same method called same key to decrypt it, okay, and will get the meaning or will receive the message. Now do you see the problem? It seems to solve the basic problem that we got from the way one. The problem was that B, they had to move out, they had to make sure that no one was there when they were meeting. This problem was is not there anymore in this way, second way, where they are using a key to encrypt and decrypt the message, okay. But can we see more problems or different problems here? The problems here are with this way. Problems with way 2. Let me yes, sorry. Problems with way 2 is, first, they both need to know the same shared key to encrypt and decrypt. Make sense? So they both need to know the key to encrypt and decrypt. So anyone with the key will be able to decode the message, will be able to decrypt the message. So we have some sort of a security concern here. So how to navigate now further? So what we can do, and what we can do, we can use. Let me, yeah. What we can do here is also, before moving on, this is called as symmetric key. This is called as symmetric key. So, or sorry, this is called as symmetric encryption. Okay. Now let me write it. This is symmetric encryption, where it is using only one key, okay, to encrypt and decrypt the message. Another way is, I will decrease it, uh, 0. Okay, yeah. So we see here is, this is how we this is the way one. Now to see if we do have any other way, we have one more way to solve this thing. The way is way 2, way 3. Way 3 is, now we are going to use to a key pair, and in this key pair we are going to have two keys, okay. One key is being used to encrypt the message, and the other key will be used to decrypt that same message. What I mean here is, if one key is being used to encrypt the message, that message can only be decrypted by the other key of that key pair. right? It cannot be used, sorry, the other key cannot be used to decrypt that message. So I have one key, key 1, key 2. If my message is encoded with key 1, it can only be decoded with key 2. If my message is encoded with key 2, it can only be uh, decrypted with that with the uh, key 1, vice versa. Okay. Now how it is going to solve our problem, let's see that. Key pair. Okay. Let's see one more thing. Uh, between from these this key pair, one key will be used to encrypt, other will always be used to decrypt it. Okay. Let's see. We are going to share one key which is always be accessible by all the people, all the users over the network. So we will call it public key. Okay. The other key, which is, so this public key is shared across network. The other key is going to be private, and it will only be accessible by the owner of that key pair. Okay. Private, accessible by only the owner of that key pair. Okay. So we have understood there are going to be two keys: public key, which is shared across the internet, and the other key is going to be private key. Only owner has the idea about that key or can use that key. So how we are going to use it is, let's say, yeah, how we are going to use it is, let's say I have a user. Now same thing. Uh, this user A wants to send a message to user B. Same message, hello. What this user is going to use? This user is going to use a encrypt using B's public key. Okay. Why? Since A wants to send a message to B and they both are on the network, and public key is always shared across, accessible across the internet. So A will use B's public key to encrypt the message. Okay. Now, message. Okay. Now we'll say, copy it and then paste it, and simply it will be received by the user B. Okay. So this message is an encrypted message, encrypted message. Okay. By public key. Now B will receive it, and B will use what? Use its private key to decrypt the message. So now B will use its private key to decrypt the message. Now let's understand more. Can this be decrypted by any other user over the network? No. Why? Because this was encrypted by public key of B only. So this will always be decrypted by the private key, the other key of that pair, which is going to be the private key of user B. So even if any other user will be able to access this message, they will never be able to decode it. So this is how this key pair is going to help send this message uh, across the internet. And how it is solving the challenges that we face in the V2? We are not this since we are using private key or two different keys to encode, encrypt and decrypt. Even if the people have the access of this public key, they will never be able to decode it. So this seems to solve the challenges we face in the V2. Okay. Now we are going to use one more way, which is going to help us explain one more scenario. Let's say I am using uh, okay, yeah. So let's say here I will use what? Here I will use, sorry, okay. So here I will again, this is in message, okay, and this is, here I am going to have a another user B. So they want to send this message, okay. So what are they going to use? They can use one, first they can use public B's. First A uses public its private key to encode it. So we are going to have, let's say I am going to have encode, encode 1. Here it is going to have, so what here it is doing, it is encoding first time, it is encoding its private key, sorry, it is using its private key to encode it, okay. So here it is going to further, again it is going to, then it is going to use, here again it is going to use now B's, just follow me here, B's public key over that encoded message to encode it again. So here it is encoded second time. So encoded one message, encoded one message is this. So used its private key to encode the first time. Then it used B's public key to again encode. Now it is going to send this message to B. Okay, it is going to send this message to B. Okay, now B will use do what? This going to, let's say, sorry, this going to send this message to B. Now this is how it is encoded message. Now B receives it. When B receives it, it is going to use, how? It is going to decode one. It is going to use what? It is going to use its private key to decrypt. Okay, now it can decrypt it only, why? Because second time was used, second for second encryption B's public key was used, so it can be decoded only with B's private key. So B uses its private key to decrypt it. Now it will use again uh, public key of A to decrypt again. And how and why it is again improvement here? Why? Because this is going to be decoded second time, because here we are proving the authenticity. Here it is benefiting us by proving the authenticity. Proves authenticity. So it proves authenticity that this message is being sent by A only, and this is the basis of digital signature. So this is one more way how we are using this key value pair to encode, encrypt and decrypt. And this is what is called asymmetric. This is what is called asymmetric encryption. Asymmetric encryption in cryptography. So one more thing that I want to discuss about is where are we actually using this asymmetric encryption. We are using this asymmetric encryption in a very famous protocol called as uh, RSA protocol. Also, this is being used in SSL termination. This is being used for HTTPS to authenticate, to make sure, to have a communication over internet in a secure way. So thank you very much. Hope it has helped you in some way. Thank you.